Algebra 2, Lesson 6.6, Function Operations. In this lesson, our objective is the student will be able to perform function operations and determine composition of functions, or composite functions. And I just wanted to remind you at this point that we have function notation. This is read f of x equals 3x plus 2. And this is kind of like just where the y would go. The function of x, and here's the x, that's the function of. So, but usually we usually think of this as just being y. Okay, so what we're doing with this particular functions this time is we are going to be performing operations. So we're going to have not only f of x, but g of x. And the same thing, it's just saying it's a different function. And so here's some examples. We're going to say, well, if we have function, but we're going to look, we're showing that you can add, subtract, multiply, and divide functions. So look at, so if I have f plus g, those are my two functions of x, it's just like f of x plus g of x. So here's my f of x. I'm saying if f of x is 3x plus 2 and gx is just 5x, I can add those together, and of course I can add like terms. I get 8x plus 2. Similarly, subtracting, f minus g of x is just f of x minus g of x. So here we go. And we end up, once again, subtracting and simplifying. Now I multiply. Same thing. If I multiply, it's just f of x times g of x. And this, of course, we have to use the distributive property. So we have 5x times 3x, which is 15x squared, and 5x times 2, which is 10x. And then we have dividing. Dividing is the same thing. The only thing that we have to realize, though, is that if x is 0, that's going to make this an impossible fraction. So we have to be careful about the x's. So I have to say that it's 3x plus 2 over 5x, which I can't really simplify. But this is where x does not equal 0. And that's called being considering our domain and restricting the domain. And domain are the x's that can be used. So anything that will make an x 0, I can't use it. So I can't use x. I can't use 0 here. All right. So what does this all tell me? This says, and in general, this is telling me that you can add, subtract, multiply, and divide functions. But you must consider the domain, which is that part where it falls to 0. Because if it goes to 0, it can't be there, so I need to restrict it. Okay, so let's look at some examples, some additional examples here. I have two functions. I have f of x is x squared minus x plus 6. And I have g of x, which is just x minus 3. So let's try to do these operations with these functions. So I have f plus g of x, which means I just take this and I add this. So I'm going to have x squared minus x plus 6 plus x minus 3. And of course I can simplify that. I have x squared, and I've got minus x and plus x, so they just kind of drop out. And 6 minus 3 is just 3. So I'm left with x squared plus 3. If I have x squared minus g, I do the same thing. X squared minus x plus 6. This time I'm going to put a parenthesis around it because remember, it's subtracting the whole function here. So of course I've got to use a negative in both places. So I can say that's like adding the opposite in both places. And now I can combine like terms again. So I get x squared, and this time negative x and negative x are minus 2x. 6 plus 3 is 9. Now I'm multiplying, so I have x squared minus, so this one's going to take a little bit longer, x plus 6 times x minus 3. So this time I'm going to do some distributive properties. So I have x squared times x to the third, x, or negative x times positive x, which is just going to give me negative x squared, 6 times x, which is just 6x, and then I go back and I do everything with the other term. X squared times negative 3 is negative 3x squared, negative x times negative 3 is negative 3x, and 6 times negative 3 is negative 18. Okay, so let's see if we can do some simplification here. We've got x to the third, x squared, and there's a minus x squared and minus 3x squared, so minus 4x squared, 6x minus 3x is plus 3x minus 18. So that would be multiplying my functions. And finally, dividing my functions. So this time I put x squared minus x plus 6 over x minus 3. Well, once again, I have x minus 3, and I cannot have that equal to 0. And the x that would make that equal to 0 is 3. And I have to look at this part. So x cannot equal 3. However, I'm looking at this polynomial and I'm realizing I can probably factor it. I know that negative 3 times 2, or negative 3, maybe not. Negative 3 times 2 might not work, so maybe it won't factor. But if I could factor this, I might have something that drops out later on. Okay. Anyway, so that is an example of doing all the functions, operations with my functions. But what happens, and then in that case I was doing the operations together, what happens if I do one function after another function? For example, if I have x equals 2, and then I had, and I put it in here for f of x, so I put in there for f of x, so f of 2. Remember when we say f of 2, that means we're just putting in 2 for x. 2 squared minus 2 plus 6, that's our one from last time. 4 minus 2 is 2 plus 6 is 8, so f of 2 equals 8, and g now of 8 equals 8 minus 3, which is 5. So sometimes, I could take this and then plug it, what I get into there. When I do that, it's called a composition of functions. Composition of functions. And this means I have g composed of f of x. The function g composed of, that's a little tiny 0, it's supposed to not look like a multiplication symbol. G, the function g composed of the function f of x. And it just means that I'm going to do this first. It's like putting this into parentheses. I'm going to do f of x first, and then whatever I get for f of x, I'm then going to do g to it, function of g to it. So let's see how this looks. So, an example here. If f of x equals x minus 5, and g of x equals x squared. Let me get these out of underneath so you can see. what is g of x for negative 3? So I'm going to put negative 3 for f of x. See, I've got g here, and x minus 5. So I just put negative 3 minus 5, and that ends up being negative 8. And g, well, g of negative 8, well, x squared is g, is the function for g. So I'm going to put negative 8 squared. Negative 8 squared is, and then we put it in parentheses, 64. So that is my composite function, g of x. Now, let's see what happens if I put f of g. So this time I'm going to put the g first. I'm going to put, actually, f is going to be in the parentheses and have the g in the middle. So I'm doing g first. G is x squared, and I'm starting with negative 3. So negative 3 squared is going to be just 9. So and that's all. And I'm going to find the f of 9, and my f function is x minus 5. So I'm going to take 9 into that and put 9 minus 5, and I get 4. So my function f composed of g, negative 3, is 4. And what I want you to notice is that 64 and 4 are not the same, which means that I can't just flip-flop my composite functions. I have to do it one way or the other way. Okay? And this is where it really has a lot of actually everyday applications. So this is like the first time in a while that we've really been able to talk about real-world applications of this. So I'm going to give you an example. And you're going to realize, hopefully, when you see this, that these happen all the time. There's all kinds of things that you can do, kinds of everyday applications that we have with composite functions, believe it or not. We just don't call them that.